A relation is any set of ordered pairs. So basically that means any random set of ordered pairs that you are given or that you pull off of a graph makes a relationship. And if you think about it, a relationship is how the two variables on the graph are related, how the x-axis and the y-axis are related. And so one thing in math do we have that pinpoints exactly the location of those two variables and where they match? An ordered pair. In an ordered pair in a relation, you have two parts, a domain part and a range part. To find the domain, all I do is I look at the x coordinates, the x values of each ordered pair. 1, 3, 5, and -2. If any ordered pair any x value appears more than one time, I only have to write it in my domain one time. And the range is the exact opposite. It's the y coordinate in the ordered pair, the 2, 4, and -6, and -10. You can show a relation in 3 or 4 ways. The first way is obviously, like we talked about, a set of ordered pairs. Another way you can show it is a table by listing out the x values and the y values separately in columns. You can also use a thing called the mapping diagram. A mapping diagram is where you take the x column of the table and you list it in a circle there. And you take the y column and you list it in a separate circle, and then you match which x goes with which y by drawing arrows. And a third way you can do this is by simply taking the ordered pairs and graphing them on a coordinate graph, just like we've been doing. Go ahead and give these a try. And there's the mapping diagram. Notice in this mapping diagram, both -1 in the x value and 7 in the x values match with 3 in the y values, because if you look in the table, -1 and 3 and 7 and 3. But we don't write 3 twice in the range, we just list it once and make 2 arrows going to it. Give this one a try. And this one. Okay, now we're going to learn about a special kind of relation. So relation is any random set of ordered pairs. Remember, by definition, it is a random set. So there's no rhyme or reason to it. There's no pattern necessarily. There's no rule. It's just some points that I picked on a graph and listed them out in ordered pair form. A function, however, is a very specific, special kind of relation that has only one y-coordinate for each x-coordinate. Another way you could say it, it is a relation that has a pattern or rule to it. It sort of makes sense. When you graph a function, all of the dots on the graph that you make will line up in some fashion. They'll either be a straight line going up or down, or horizontal or vertical. You'll notice a pattern. They're not just plotted kind of all over the place. And a third way you can think of this is that no x-coordinates can be repeated when you have a function. And that's important for later on when we actually determine whether a relation is a function or not. So keep that one in mind. No x coordinates can be repeated. Here's some other things that describe a mathematical function. You don't have to write these ones down in your notes, but these are really important to read over and to remember. I would definitely make sure you have these in your notes. This is really important, how to test to see if a relation is a function or if it's just a relation. You can use the graphing method, and we'll learn about that. Or we can use the table or mapping diagram method, and we're going to learn about that as well. The graphing method requires that you learn the vertical line test. It's very easy because it takes a vertical line, some arbitrary vertical line like a ruler or your pencil or your finger, and moves it across the graph from left to right. And as you move, you determine whether it passes or it fails. If it passes the vertical line test, that means you have a function on the graph. If it fails the vertical line test, that means you do not have a function on the graph. Let's look at what it means to pass or fail. So you draw a vertical line through the graph. I don't like to draw a line. I like to actually take one and move it across the graph because you want to see all the parts of the graph, not just one part. And what you're going to look for is how many times does that vertical line that you moved across the graph intersect the actual points that are connected on the graph. If they intersect one time, then it passes, so it's a function. If it intersects more than one time, it fails. It is not a function. Let's look. Is this graph a function? Well, if I were to take a vertical line and move it across from left to right, it would come really close on both ends, but it wouldn't actually ever intersect that red line more than one time. And here's a good example of that. It intersects just at that bottom there. It only crosses at one point, so we have a passed, so it's a function. Go ahead and try these other examples on your own. Now that we've learned about the vertical line test, we're going to see if there's another way to determine whether something's a function. Because we don't always have a graph. Remember, we can have a mapping diagram, we could have a list of ordered pairs, or we could have a table as a way to show our relation. So we need to have a method to see if it's a function or not if you don't have a graph. And remember, you can always graph the points if you didn't remember this method but you like the vertical line test. But let's look at it. If you're given a table, if each number in the x column appears only once in that column, then you have a function. So let's see, is this relationship a function? Well, if I look at the x column and I look down, I see 1, 2, 3, and 4. Each number only appears one time, and so I have a function. How about this one? 7, 9, 10, and 10. Well, 10 obviously appears more than one time. It repeats. So I do not have a function. And what about this one? Every number appears only once, so I do not have a function. Try this one. Is this relation a function? A little tricky because it's listed in ordered pairs, and we don't have a test to see if it's in ordered pairs. So what you can do is you can either graph them and use the vertical line test, or list them in a table and use the test if the x values repeat or not. In this case, none of the x values repeat, so this is definitely a function. And you see that if I list it as a table, 3, 1, and -2 are all different. Let's test this one. Is this relation a function, this table here? Hopefully you said no, because -3 repeats itself. It appears twice in the x column, so that is not a function. And we'll learn about inverse a little bit later, but just write down the definition for now.